So let's get started. We just some admin stuff first. Just to probably I'll announce later in the Blackboard as well. One thing is I will be out of Hong Kong for an admin meeting, so that's why I think we'll cancel one class, which is the November 4th. We'll cancel one class, but I will not make an announcement later. I will decide when to do the makeup, or actually do we need a makeup, but let's see, because I mean we are on the right track. Maybe we can have another section that do some Q&A or whatever. Let's see what to do, but I guess at this stage we don't need to have that because of the way that this year proceed is much faster. But let's see what happens. I mean, I guess well, I would prefer to have a makeup, but I guess you may not prefer to have that. So let's see what do we need to do that. So very quickly, we just quickly review what we have been doing. I mean, we will finish this set of slides, estimation, and then we'll go to hypothesis testing. So estimation, simply speaking, as we recall, will be we want to know what happened in the population, basically based on sample, right? Look at the small picture, the data you have, to guess what's going on. In the big picture, is things we want to know, right? Just like election, you want to look at the result, but we will not know until the day, but we want to know now. Then what you do is just pre-select some of people that are likely to vote, and then we know how they vote, and we know, right? Same as what the business application is. We want to know how much people will spend on your product. Of course, you will know on the day when your product comes out. But before it comes out, you want to test it, right? And then you want to select some of the customer to see how much they're willing to pay and how likely they're satisfied with product. And these are the way that you would care, right? And the thing that we would usually interested in also the summary statistics, right? Like the mean, the variance, right? These are the two numbers that we care. Of course, we also care the kurtosis, skewness, or max, or mean, or other quantiles, or median, or mode, or all those other things. But that would be beyond the basic class that we're doing, right? Your basic stat just cover the most basic thing, the mean, right? Even the variance is something that is even beyond our scope. So we focus on mean, and because the mean is the most important, as we argue already. And do note that it's a parameter. We don't call it variable because it's not random variable, right? Some number that is there already, but we just don't know. So there's no uncertainty there, okay? In classical sense, there's no probability you can assign. And estimator is the way you estimate, right? Because and this is how you estimate based on the data you collect, right? It's a function tell you that, okay, how you estimate those, right? The example will be the population mean is estimated by the sample mean, right? Sample mean is not a number, sample mean is a method, right? Where if you given data, how you convert those data into a number, and that number is estimated population mean, right? And that's why it's a function, and because this is a function of a random variable, and that's why itself is also a random variable, right? It's a function, you say, but itself is a random variable. And estimate is a particular number, right? And then we know that there are two types of estimator, and then we talk about the first one in the last class on Monday, where the point estimator is a particular number to guess, right? We try to say want to guess what is the population mean, right? If we just use a number, that is a point estimate, right? This number that we come up with, that is the thing we guess, right? Just remember the metaphor we have is we try to shoot somebody, right? Is some bad guy, right? Not good guy. So bad guy there, the bad guy want to shoot the terrorist, whatever. Then you use a pistol, then we just hit 1 point, right? Or arrow with a bow, we just hit 1 point. But if you use a machine gun or a rocket launcher or whatever, the atomic bomb or whatever, go nuclear, then you will bomb the whole area, right? So the area of attack will be referred to interval estimator, okay? And that is the idea that we'll talk about today, okay? And just to recall, the point estimate have three important properties that you would like to satisfy. First one is unbiasedness, is on average is right? Individual may not be right, but suppose if you collect the sample many times and average of those will be correct. Okay? And efficiency or on expectation is correct, right? It's not correct, but on expectation is correct. And efficiency means that build upon unbiasedness, right? If two estimates are unbiased, they on average are right. The one that is smaller variance, right? More accurate, it's better, right? Efficiency means accuracy, right? In terms of that, right? Given that on average you're right. And last one is consistency. Consistency is the weakest of all, right? It just requires that the sample size is sufficiently large enough that we arrive at the target, right? Hypothetically. So basically, the last one is the less demanding. Okay. So whenever, although it's technical, but that is the least requirement, right? It's saying that, right? The idea is like the following: we have a problem to solve, right? Then we can't solve it with one solution, right? But this should not be a problem if we have enough money, right? There's a problem is because we don't have enough money. If you have money, you can solve it, that's not a problem, right? But the problem is, it's a big problem if enough money cannot solve it, right? So there's a big problem there, right? So the same idea. If you have enough sample, you have enough money, you can solve it, then it's a good thing, right? So consistent idea, right? If you have enough money, the resources, you can solve it, right? At least we can achieve the great outcome. It's consistency. Okay, that's the weakest requirement. Okay, and unbiasedness is something that is second desirable property, right? Because it needs to be true even n is not infinity, right? Any n is small, any number, right? We just have to collect many of those samples and average that's right. So that's the second requirement that's required, right? Upon if you're unbiasedness, you want to go efficiency, right? If they are nice, you hit the target on average, you want the very small as possible. And the good thing is, if sample mean satisfy all three property there, right? And if you want the sample variance also satisfy that property there, right? Okay, that's why it's nice that we use it, right? Just to remind you that why we differentiate the population variance and sample variance. Population variance is the property of the if the population want to study, right? That's calculated by that. But if you want to guess what it is, okay, the method to use you have to is n-1, right? To note the different n, right? N is the sample you collect, n-1. But the whole thing is the whole n is different, right? The different thing. So although they look the same, it's a little bit different, right? Also, the sample variance is the sample mean, right? That's there. Okay. Of course, if you look at the proof, the main thing is we have to guess this guy. If you look at the proof, if you know the mu, if we know the mu, I mean, I don't know how we know, but suppose we know the mu, you don't need to divide by n. You can do n-1, divide by n is fine. So the problem is because of you have to guess, we're guessing the sample mean. So that means that that's what we call degree of freedom. I mean, you can look at the proof, but that's the reason why you have to divide by n-1 to get the right result. But I'm not going to elaborate the proof. You can check it out. It's not 3 pages of slides. And I guess only a few of you would care about the proof, and the majority of you don't. So that's why I'm not going to go about that. But it will be rewarding to read the proof if you want to. That would be something like if you want to go further on the quantitative studies, then that's something that you should able to be comfortable to handle them, right? And lastly, talk about standard error mean, right? Which is saying that, okay, we come up with the mean estimate, right? Then we just how accurate it is, right? Can be represented by the variance of that, right? The larger the variance, the less accurate, right? So that is the idea, right? Then we know that that is coming from sigma over root n, and we don't know sigma, right? So can estimate that how accurate of your sample mean is by this one, right? It's s over root n, right? And we know x bar is approximate normal, right? So that we come up with some probability measure, right? The bell curve, right? And then we're able to do something about that. And this is the sample proportion. We talk about that, right? And because sample proportion is just the sample mean, right? There's nothing new here, but the only difference is because of the fact that in proportion, mean and variance are related right? Because I know the mean, I know the variance directly if this is a binary data. And the variance actually you can come up with is one way to estimate this guy, because I know the pi, right? Through the p, then I can estimate the head, right? The standard, the deviation for that, right? And but the problem, this is bias, right? But usually in the textbook, never talk about those. You look at the textbook, they never tell you why we use a bias one. One of the reasons n is big enough when you do a binary data, right? In that case, the adjustment will be minimal, okay? And in fact, there's a term we call asymptotic unbiasedness, where n go to infinity, the bias would disappear. Okay, so that is an even weaker thing, but it's not going to cover in our course. But it's not a big deal. When n is big enough, the bias very small, and we have large n, so it's not a big concern. Okay, for us who do this binary data, and this is the variance standard deviation. Don't worry, we'll immediately use it today's class. Use up this standard error, because later you will see with plus minus 2, SD will be the way to go to estimate, to come up with a good interval estimator. Okay, so interval estimator. Just want to remind you why we need that. I mean, I just convince you that we have the, I think it's good to, again, look at the typhoon satellite picture, right? I think that is one of the reasons why we need them. And then I think the Microsoft beam is a little bit different from, so you will see, this is the good one again. Or maybe even this is better. I don't know, but I guess this is not the look, the Hong Kong one better, right? This one, yeah, right. As you can see that again, another typhoon picture, right? The solid line means what, the historical path, right? And the dotted line means the point estimate, right? And the yellow is actually the interval estimate. What the interval estimate means that instead of estimate particular location, you estimate this area location. That is likely, highly likely possible. Okay, why you want to have that, right? What's the application of that? Why? Because suppose you're a fisherman, right? You have a boat down there in the Pacific Ocean, right? Do we need to worry about it, right? Of course, if you just given point estimate, the dash line, then of course you would be, well, if you are in the yellow region, right, somewhere next to it, do we worry about it, right? How close you should worry about it, right? And is it 1 km enough, 10 km enough, 100 km enough? We don't know, right? The absolute distance may be reasonable enough, but that's not sufficient, right? So what we want to know, if you're a fisherman down there, is how likely that we got hit, right? So if I draw and say, well, we solely the 95%, 90%, confidence that, I mean, if you imagine that this is a parallel universe, look at out of 100 universe, 90% of typhoon way goes, okay? And that will be the yellow range. Then in that case, out of 1 out of 10 universe, it heated, then we don't care. In that case, then if we are somewhere outside the yellow region, then we are safe, right? Kind of safe, I mean, or less worry about that, right? Or at least we would say where will be safe, right? If we are outside the yellow region, then we have to be careful, but we don't really worry too much about it, right? So that's the idea, right? Instead of talking about a single line, right? We consider a case where if we imagine that this universe is repeated 100 times, right? Imagine we have 100 universe from now on, right? Split from now on, then we count 90% of them, right? Is it going to be there? Somewhat like this, okay? Somewhat like that idea, okay? So let's go back to the interval estimator, okay? So we actually know that X bar is a good estimator, okay? The point estimator without any assumption there, right? regardless the underlying spell or non-bell, that is good. Okay. So the next question will be, can we say more, right? Because we know we can estimate the standard error, right? How bad and how good it is, right? But now we can't proceed further saying that the variance large or small, and that's what can say, right? They say variance is, or the standard deviation is large, then it's accurate or less accurate. We can't give a much more detail on the estimation, but if we are willing to make the assumption like the following, we're going to make the assumption that either we have large sample, right, or we assume the underlying is a bell. Both of them will deliver the following, right? The sample mean following the bell curve. Okay, with that we can do a lot of stuff. Okay, if this is the case. Okay, why? Because we can construct an interval. Okay, that is a little bit more complicated. Please pay attention because this is the part I think is among beside hypothesis testing, this is the most conceptually complicated idea that you have to learn because this is rather convoluted. So the idea is that we need to construct an interval that's going to be around X bar, okay, that has high probability to include mu. Okay, so let me draw a picture here because I think that would be helpful, because I'm not sure I have the picture in the book. Okay, so we know that now we have a bell curve thanks to central limit theorem or normality assumption. Okay, you can either assume either this is given. Okay, and we know that it's unbiasedness, right? Also any nice property that will be centered to mu. Okay, so the question is, when we collect data, it can be anywhere in the bell curve, right? We just know how it looks like, but it can anywhere, right? How can we proceed, right? And also we know that the variance of this is going to be sigma square over n, right? So this is the variance of this bell, so we know exactly how the bell looks like. So the question is, can we construct an interval, okay, X bar, such that you will highlight include the mu? So what do I mean by that? So of course, if we're lucky, the data is exactly mu bar, then we're lucky, right? But that's not possible. We know this probability 0, right? We're likely that we're never going to hit that. So suppose we're here. We don't know we're here, but suppose we're here, okay? What we want to do is we want to go left and right by the same quantity, okay? And let's call this the textbook idea that's called marginal error, ME, go left and go right, okay? And what I want is, whenever I got this, I go left and right, okay? And I want this green interval, okay, will include mu with high probability. Okay, let me state it again. That is very convoluted concept. Is I want to, because the data, right, will depend on what you draw, you end up in somewhere along the line, right? And once I have the collect data sample mean, I go left and right by margin of error, okay? And the margin of error ME will be something determined by a formula. But what I want is I want to go left and right, okay? Such that this will include this highly likely. So what do we mean by that? Means that if I want the X bar is a random variable, okay? So which means that I want the mu will be within X bar plus ME, right, which is the upper end, X bar minus ME, okay? I want this thing to happen very often, okay? Do note that mu is not a random variable. The random variable is X bar and ME, right? Because X bar and ME is a formula, it's an estimator, right? I want this to happen very often, okay? And that is what we want to do. Okay. And now, how do we find ME? The question probably is how do we find ME? How to figure out this? How long is the extend your hand in order to make sure that a lot of time that you end up including the mu, right? Because you can do many sample mean, right? That will be the question. Okay, is that clear what we are asking? Okay. So how do we think about this problem? Okay. Turn out to be is a little bit convoluted. The idea is like if I can touch you, right? And if our hand is same length, then you can touch me as well, right? So that's that concept, right? If I can touch you, can touch me. So it doesn't matter who touch who, right? So instead of thinking about X bar extending his hand left and right, think about the mu extend the same distance left and right. Okay. So we change the question, asking this another question. I will extend this by ME, and I extend this by ME. Okay. I don't know that, but if I extend ME, then X bar will fall within the orange interval, right? That can be done, right? So we write it in the formula the following. It just X bar is within mu plus ME and mu minus ME, right? The equivalent thing, right? So I want X bar and touch it, or mu actually go left and right. Why I do that? Because I know how to calculate that, right? Because I know there's a bell curve. If I know the mu, I know the sigma square, I can construct 90%, right? Because if I want a high probability, this thing will happen, right? If I want this to happen, right? Suppose this is called 1 minus alpha, which you see. If symmetric, this is alpha over 2, alpha over 2, right? Alpha is usually 10%, okay, or 5%, right? So middle 95, right? So if this is the bell curve, right? And this guy is what? This guy is, if you recall that, this is actually Z alpha over 2 sigma over n root n. Why? I mean, of course, plus mu. Okay. Why is the case? Why is that thing? Because if you recall, okay, this is X bar. If this is mu, okay, I want this to be 1 minus alpha probability. Okay. Then will be, you can convert this to logical Z, right? Which is 0 here, normalize it. Okay. And if we want this to be standard normal, right? This is alpha. Okay. I would denote this point at Z alpha over 2. And why do we call this alpha 2? Because the definition of Z alpha 2 is the tail area. So if center is 1 minus alpha, just a number there, of course you can use the FT set table to do it, right? This 1 minus alpha and this alpha over 2, right? And this alpha 2. Okay. And why this number, what this number is? Remember how you convert from the top to the bottom? It's minus the mean over the variance, right? So you convert it back is multiplied by the variance over the SB and plus the mean, right? Repeat the statement. If you go from not any normal bell curve to the standard normal, you minus the mean over the SD, right? So if you reverse the process, if you know what's going to happen down there, go up, you just multiply by the SD and plus the mean, right? So that means that that number will be mu plus Z alpha over 2 sigma over root n, right? So don't worry, this formula are in the notes. Okay, just I want to illustrate in the graph first before I go to the more formal. So that means that I know the interval, right? Basically, the interval ME is just this guy. Z alpha over 2 times sigma over root n, right? So that actually we have the formula already. Because give me x bar, I plus minus this guy, right? Because ME is this guy exactly. So this is the ME. And this is the ME. Okay? Don't worry, this is the graph. I'm going to go to the math. Okay? But just to overview what we're doing. Okay? Don't worry if you don't get it because I have to taught it several times before you eventually get it. This is something very convoluted. The reason it's convoluted because it's not probability. There's some probability before you do the sample, but after you do it, it's not probability. So that's why we call confidence interval, not probability interval. So that's some issue here. But anyway, let me go to the formula, but that's overview what we're doing. So if you don't get it, doesn't matter because we're going to go into more detail. Okay? So again, what we want, the definition like this. We want that, okay, to find an M such that I add it and minus it to include the true population mean with high probability alpha, okay? Of course, you may say, I want alpha to be 0. I want to include always, then it becomes infinity, right? Because normal is in anything is possible. So we have to have some trade-off to be reasonable. We can't always include a true population mean, so we have to make alpha as small as possible we want, which that alpha is usually 1%, 5%, 10%, right? Because I want the mu here, I don't know, but I want to collect my data. I want to subtract and minus, add and subtract M, right? To form an interval to include, just like a typhoon, right? I estimate the mean path. I want to calculate the up and down to the area that we included, okay? So we will show this is the case, as I argue already, okay? That is coming from the bell curve, right? The bell curve will tell you that Z alpha over 2, right? It's a tail area is alpha over 2. Okay? Don't worry, you will see this very often, this guy. You'll be the rest of the semester, unfortunately. We'll see this very often, okay? So that with the idea, the formula is like this, is you x bar plus minus this guy, that will be our formula, okay? So first, accept this formula first, I will explain again. But I already explained the underlying reason, but that will be the formula. If you don't know, just plug that in, okay? And this comes out an error. And because you go left and right, 2 times of the width, right? The upper one is larger, the lower one is lower, okay? But I will try to convince you this is the right formula. Again, how to prove it, okay? So let me prove it for you because I think this is worth reading the proof. This is the part, but you don't have to know it because you just remember the formula. That would be sufficient, all right? So the main idea is we want to find this happening, right? So the thing to do is you can look at this one. You can add M, right? That gives you, so you can look at this inequality. It's here. You add M, right, to the both sides. This gives you this guy. And look at this inequality. You subtract M, it gives you this guy. So these two are the statement, the same thing, right? As I tell you, I touch you, it's same as you touch me. I think it's Newton's third law, right? If you interpret it that way, action and reaction, all right? If you can touch me, I can also touch you, right? So, and now because the mu on both sides, right? You can subtract mu, right? Once you do that, you can divide both sides by that. Why I do that? Because this is, according to the formula, this is standard normal is that, which is normal CO1 if you like. Okay, and that is just saying that this is what we want, right? Because once you have this, right, central theorem said this can be considered Z, right? And we already know that if this is central limit theorem, sorry, this is standard bell curve, right? If we want this to be 1 minus alpha, the formula is Z alpha over 2. This is negative Z alpha over 2. Okay? And probably you would say, okay, how can I find it in the Excel? Since we don't care about notation, right? But suppose this is like, suppose alpha is say 0.1, right? And this is 90%, right? Right? And that means that these two areas must add up to 10%, right? And you divide them both sides equally, so it's 0.5, and this 0.5, right? And that means that this guy is, you can use norm, okay? Because standard normal, we have somewhat easier. S dot inward, okay? Standard normals dot standard dot inverse, and you can put a number here, right? Because inward is, you give the element on the left, I give the number, right? So either you use 0.05, okay? Okay. So there would be something like this. I'm over at Excel. So I would use the norm S inverse because they're normal, okay? And 0.05. Okay, that will be the answer I have. Okay. If you don't like this one, you can still use the standard version. Norm inverse 0.05, mean is 0. Okay, variance 1, the same thing would happen. Okay, that actually give you the left-hand side guy. Of course, if you don't like this, you can also do the norm as inverse 0.95 because you want to look at this number. Okay. Also give you the same formula because this is symmetric. Okay, so this will give you the number. Okay, and once you have this number, right, this number is exactly this guy, so you can rewrite this is the idea, right? So this is formula why M is like this. There's a math behind, but I think I already told you what's the intuition. So if you get it, you get it. You don't get it, just remember the formula, right? It would take a long time before you really appreciate it. At least for me, it took me like 3 or 4 weeks to appreciate what's going on. I check. When I learn it, I don't understand. Then I go to the central library. I think they're still there. First floor is there's a business that section. I pick up like 10 textbooks, read different of them, and then after a few weeks, okay, I got it. Of course, I know how to apply this. Very simple, right? Just look at this number and just put it in. It's very easy. But the thing is, appreciate what's going on. It's not that easy. Okay, but I hope this is the formula. Okay, so this is the formula we give you before the break. Then you know what's going on. Okay, so hope that you would do it. Okay, so the idea is the following. Suppose I know the standard deviation of population is 4. You probably ask how I know that. Don't worry, we will talk about the case we don't know. Okay, this is suppose we know that. We will tell you how to do it. We don't know. Very soon we will student T, but that is the hint. But suppose we know that. Someone tell us. Okay, and we have a sample size of n is 64, and sample mean is 3. Okay, the question is, okay, sample mean is the best thing if we want to say what is my guess of population mean. That will be 3. That's done. I'm done. Okay, But the question is, we want to know better because we have the population SD, right? Which is 4. Can we use that? Okay. The formula already given here, right, will be just the following, right? We call the formula just here. Forget about the complicated math here. We just x bar plus minus z alpha over 2 sigma over root n. So this is the formula that you have to have that in your mind. Okay, of course, you don't have to remember, but you know this is the formula when we talk about interval estimate, right? It's x bar plus minus something. And what something is this formula, right? Do note that the sigma over root n is nothing new but the variance of this guy, SD of this guy, right? So there's nothing new there. There's nothing over root n here because why over root n? Because this is sample, the variance is smaller, right? We learned that, okay? It's random with a random sample, so that's why you have that. So how do we handle it, right? Sigma is given here. So we've done this guy, right? And n is done because this depends on sample, we're done here, right? Of course, this guy is already know, right? Otherwise, what we're doing, right? So the only left is this particular guy that deserves some attention, right? It's a bell curve, right? We want a 95%. So that means that in the middle is 95. Middle 95. So the 2n add up is 5%, right? 95 in the middle, 5 total at the left and the right, right? Left and right is 5 is 2.5 each, right? So this means that is z is 2.5. So that's norm dot s dot inverse 2.5. Give me the number. Or you want to say it's 97.5, right? Either you use 0.025 or 0.975, right? Will give you 1.96, okay? To show you this is correct, let's look at this here. Either you use norm S inverse 0.025, okay, which gives you the negative number, or you want to use norm S inverse 0.975, okay? So both of them will give you the same answer, left or right, because it's normal, it's set at 0, okay? So once you have this is close to 2, indeed, that is the idea where you have a 2 SD rule, right? Very often, we talk about the mean is here, we add 2 SD. That will be our estimate, okay? Later you will see this is almost right when n is big enough because we apply the student t, that would be fine as well. But that is where the add 2 SD comes from, 2 sigma rule, okay? If you look at many management textbook, right? That's what you guess. How you guess, right? They teach you, okay, I have sample mean. That's my best guess. But if you want me to guess better, give me more room to maneuver, I would add 2 SE or SD, right? And minus 2 SD. That is my best guess. Okay? So that will be the part we have. So again, as I reiterate, the green part is you have to master, right? The green part is application of the blue part that I would ask you to know. So if you know the green part, then you're safe because this is the part that will appear in assignment. You need to do your own project and so on and so forth. All right. So that is something that I hope at the end of this class, I'm pretty sure everyone would forget most of the stuff, right? But I guess at least you pick up the slides, come back, you know how to do the green thing, you know how to proceed because that is the way that that actually most of the things would be needed, right? You understand? The reason behind is good, but it's not necessary, right? Because we can't understand everything, right? But hope that you would be able to remember. Okay. And so before the break, let me give you a very some remark on this interval estimate. Okay. So you will probably ask why we call confidence interval, not probability interval. Okay. The reason is due to the classical definition of probability. Probability can only be, say, for something that hasn't happened, right? If something happened, it's whether you know it or not. There's no probability, right? Either is or not, right? So suppose I met a beautiful girl here. Is whether I like her or I don't, right? There's no probability. Or I don't know whether she loves me or not. It's either she loves me or she doesn't, right? There's no say she loves me with probability 0.5. No, there's nothing like that. It's whether she loves me or not, right? So that's why when you see the old drama, right? And there's a boy, maybe a girl with a flower. She or he remove a petal. She loves me, and then she doesn't, and she did, right? There's no probability. There's a 90% she loves me. 89, there's nothing like that, right? Just either yes or no. There's no question. So there's no probability there. So that's, but we still want to say something, right? We need to say confidence level, right? Because once we collect a sample, we calculate data, there's no probability. We can't say probability, right? But before we do it, there's a probability, right? Because before we collect the sample, there is a 95% or 90% that include the way you do will include. But once we do, there's no probability. Let me repeat. Before we do it, there's a probability. That's no problem. But once we do it, there's no probability anymore, right? It's whether we do it, it's hit or miss, right? So suppose I want to kill a terrorist. Okay, maybe the weapon is very good. 90% that we will bomb the guy, he will die. Okay, 9%. Okay, but once we bomb it, it's whether he's die or not. Is dead or not, right? There's nothing say 90% dead. There's nothing like you can say is this. Before we hit it, yes, we can say probability. But after we hit it, we can only say we have 90% confidence. We finish, we meet the target, right? So probability only be assigned before we do things. So that's why we always say this as we'll use the confidence. That's what it means here. And so how do we interpret that? It means the following. Okay, how do we interpret it? Another interpretation is, suppose we do 100 sample, okay, and we have 100 sample mean. Okay, each sample mean we can do the same procedure. We construct 100 confidence interval. Okay, and what we're saying is 95% of them, 95 of them, would include the true mu, but we don't know exactly which one. Okay, we just know if we have construct 100 of them, 95 of them would include the thing we want to have, but we don't know which one. Okay, that is the way to interpret that, right? There's the way to say about probability, right? In that sense, right? Because we have 100 of them. In general, 95 of them will include, but we don't know which one. That is the confidence we have in that sense, right? It's not saying 95% will be include because either in or out. Okay. So after the break, we talk about how to handle when we don't know the sigma. As hinted, we will do a T. The formula is very similar. Okay, don't worry about that. And before we go to the break, I just final remark is how do we know the sigma? Okay, this is a far technical. You look at the textbook, they will tell you that one way to estimate that is look at the data, right? The data, look at the maximum and the minimum, right? And you look at the range, which is range, right? Maximum, minimum. And range, if you divide by 6 or divide by 4, is a good estimate of this standard deviation. Why? There's a theorem telling you that 90% of the data would be within 3SD of data or 4SD data. So range would be a good estimate, a rough estimate of the sigma. And there's a good reason, there's some way to do it. But or the many other way as well. But that would be beyond the scope of our class to have a good estimate of that. But the easiest way, to estimate sigma is use this sample standard deviation, and then we use the t distribution. That's another way to do it. I think we will talk about that after break. And I said this time we want to remember who attend the class and rewarding. So this time we will be. This is non-anonymous survey. Of course, I will just count whether you attend it, and at the end, I mean, from now on, we will just record who has been in the class, so that if we are able to give some bonus point, then I will based on part of it based on that. Okay. Only part of that, not only based on this one. But in case you are on the margin, need some bump up, then that will be the basis. Okay. But of course, I remember many of you attend the class, so that should be fine. But because some people said I should have more scientific method to remember who attend the class, so it become more scientific. But usually it's based on my memory. 90% of the time is correct, right? Because I can remember who's the face, and I try to bump up people when needed, right? Because usually this only matter when you're marginal, right? You don't know where to cut off there, then will be case. But usually don't worry, it's not a big deal. But it's good to have some bonus, right? You will not be, I mean, punished, right? If you're not there, but you get some bonus if you need a bonus, right? So, but don't worry. I mean, I will not look at the content and evaluate whether you have the content doesn't matter. Okay. I think they asked you to log in, right?
Yeah.
Okay.
I was trying to remember my password.
Oh yeah. You will be logged in.
Always had a lot of different snack.
That's all. Don't feel anything that's about I can remember you guys. I have seen the faces, but sometimes it can be confusing. His face.
我而家其他都係一樣啫嘛。係啊。所以而家做圖先，佢幾個字嘅。唔使聽唔知。我見到個
對話咗啲乜嘢？
佢話咗咩？心機學到啲咩？
好即時咩都唔同，冇錯，任何嘢都唔做。冇真冇出嚟㗎。大家都係都啲佢都真㗎。
我呢個非唔重要，
好重要。
但係節目冇錯，太重，我做唔到。
佢唔正，因為我哋打拳，都係要自己。
必須要
係
做得好靚，我就做我呢個。
新搞10幾年。
好玩係好玩，但係要考就唔好玩。
點解你要定義？點解一啲都唔好玩？
好熟已經係。
佢有2天係做。 我個心經之後有冇掌握到？有冇到一切斷啊？
即刻個冇啊，仲喺苦海入邊，我哋喺苦海入邊。係有陣間我哋真係 FX 嘅勉強都算勉強，其實佢算要溫書就係嘅，要溫晒，
呢個唔係計分，
佢計10分，識計不多，但係咯計分10分好多啊，其實係咯，
幾多
？accounting 嘅10分鐘多，
我升到咧就算啦。冇咩嘢睇又如果人好細嘅話就冇所謂。
應該大喎，其實
即讀係咯，讀唔讀個 variance 都冇分別嘅。
應該有分別，因為我估有啲都應該，我覺得我係會弱啲咯，應該有啲課。但 MC 有撞嘅旁邊，覺得個旁邊大，你唔可以學到旁邊有啲困散。Normal distribution，我冇呢個應該係
大家練讀咪就係 normal 啦。大家唔練讀嘅情況之下，就有人到有人讀書咁就會。
應該係，但係就算抽聲我都係講搞。可以做錯嘅，錯對真係唔玩嘅。
即係話，如果你做100個，咁有9成係0.9嘅，我試咪都有100個確實。
我真係邊個中意？其實我唔知我寫呢一層解釋啱唔啱？你望下學生嘅
開始學嘅，但係做咗之後，你而家到
對錯，即係其實佢嗰一版我唔係幾知佢想講咩，所以我冇特登背喺嗰隻寫咗個書。
因為時候啦嘛，譬如話呢個
即係
你有5成機會做，係啊，我對嗰啲真係溝佢，又呢係
睇呢條即係第2條有㗎嘛？呢個係，我跟住即係對開頭，Euro 係呢隻，即係你冇得之前有嘅講嘅嘢。即係學生其實真係認為呢啲係最 cheap 嗰隻，佢唔係佢呢條友嘅論點就係 Euro 嘛。我覺得呢個嘅論點就係新聞嘅就如果你真係用Heaven 就係藍係減1。你減息大啲，咗嘅時候，你唔知翻佢做邊行嘅，跟住有左支有右支，跟住邊個中意邊個，跟住呢條係我真係有嘗試到啲係我知有啲上最有咁我咪先我唔知啦，我覺得呢兩個即係兩個中文嘅都有啲但係呢個好難講，即係問佢開條有啲先，但係真係全部就係死好大質，你話咩？即係有咯，呢個中意有啲啊，我就寫咗混質個粒或者你覺得着手本仔個混粒係咯係咯，冇錯，呢個底嘅意思係細仔。真係仔，真係仔。寫呢啲用字咧，加埋我哋啲理解，因為呢個好怪，你嘅錯啊！呢個錯嘅，幾好睇，我覺得。所以我點解做100次？我哋跟住你好啊？
讀幾多？
啊？
midterm 嘅呢個考。
唔係，其實我哋都係一齊，其實我
都係所有都要，每個人都要。
哋今日先學。
咁 midterm 佢已經第7週啦。
係嘅，
咁啊，
我哋都 C ring 㗎啦，係8咯，
好快嘅咩？
我都堂都得翻我哋。
唔知做咗啲乜嘢先？
唔
唔知我做咗啲乜嘢就
5個禮拜啦。
仲有5個禮拜。
41月6禮拜，下個禮拜
11月最難卡。我想問你最尾個堂係
考試
呢度。
呢度考咯。
可唔可以我三定禮拜一唔好？呢個唔係幾友善，呢個做卷嘅場
有咩場？
有冇一個正常嘅台嘅場？即係一個
我問下叫天石
我唔記得係我話過。
嗰排
好頻啊！
嗰排
有冇閒置張數？
你大幾多啦？你大咗啦。
好，
我唔可以 share。
OK，
放心，
即係你可以 share。
我有晒。
你想入咩？即係可以啲唔可以帶 tablet 啊，
知唔係電子
帶
嘢
tablet 啊，唔可以帶咩反線圖啊，唔可以帶色情刊物啊，你知我乜都帶嘅。
OK，
亦唔好啲犯法嘢啦。你自己帶犯法嘢自己負責。
OK，
我冇嘢，當我犯法。
我坐定嚟禮拜一後，反正會係夜晚。夜
咪做佢哋上堂啊？
都上堂。
日講嗰陣唔係定咯。
夜晚。
長
但你唔 copy 我話翻嘅 file 到咩？
仲未成咗，
我真係真係我哋從來冇試過一個
Both make it 45 minutes. Doesn't make a difference to me. They make even 30 minutes.
only hour 唔係意思。My last one 係咪多啦？MC and like 我落去我都係。
And my all the exams are needed for every class between 2 and 3 hours.
They just want to say X.
我嘅1月。呢個場真係1 hour，
先至1 hour. Unless you want to be longer, but I think it was 1 hour.
我都係嗰啲，你有冇見佢公出嘅？叫你早先，雞嘅準線啊，好濃到，好濃嚟。
And it's a little concern because it's like whether you know good enough to figure out where to find the notes and then you're not comfortable. You know that you look and where to find, right? If you study the note findings, then you're slow. But I think most that I just need to tell you is that that's how I test. How if you know where to find the answer, if you don't know, they go, okay, what is this question? Pick up all the slide and probably get a pass. Median grade speed.
But they did a study, I think, in the US, like, what you said about like students with open note tests tend to compose work, not like all else equal. Because people like when open notes are like, oh, I'll just look at the notes when I go to the test. But if you had a restricted time constraint that like people have open notes, but still have stuff. Like you can't just like print everything out. Like, I'll study when I get there.
Yeah, that was what they did. But anyway, it's not different. That's actually a 2-hour thing. Yeah, I agree. I know how to.
Yeah.
The main thing is for me to know who is no better. How fast you find it. That's what business is doing, right? You don't remember everything. You need to look at the thing and figure out how to solve the problem. That's actually what we mean by business work.
I like that because I'm gonna tell my teachers back at home. 1 hour exam.
I mean, I was thinking that assessment and the project. I want to see how well.
我想問翻自己，
另外一半。
That's
佢卡包就佢應該冇。
That's why I said.
好優美嘅人覺得。
And on the last, I really appreciate on the last class because some of my teachers, they actually asked our class, they're like, "Hey, what do you want to have on the last class?" And everybody's like, "Yeah, we just do it on the last class." But I know it takes time. for Yeah.
We have to trade on.
又差嘅。
I think we are the right track. One class behind. I think so.
真係要
Sample. I mean, the question is discussing. So it might be good to look at how we're doing. Okay. So the question is, what is confidence level? Okay. So let's go back to the idea. Is confidence level is a kind of interval estimate, right? Instead of estimate point, we estimate a bunch of points. Okay. And what the bunch of point means that is we want to have high probability that, okay, that the interval will include the thing we want to, right? The sample mean plus minus the m, right? Instead of fishing using a rod, we use a net, right? But the net will collect the mu, right? X bar plus me minus me will collect the mu. And we'll collect the mu with high probability. That is what it said, right? But the problem is, once we collect the data, we do everything become number. So we cannot say probability interval. We have to say confidence because it is either there or not there, right? The net is there, it produces either in or out. We can't say probability, so that's why it's say confidence interval. The formula is just the formula we have. That is only remember. As I said, the interpretation is the technical part. If you don't get it, that's fine. The only way to know is what is interval, right? It's just simply this formula. You know the formula there, you know how to apply it, and that's it. And you will see from the thing, what is sample variance or sample proportion, okay? So the question is asking, what is this guy, right? So if you, this is the same thing as the sample, this is the same as this guy, if you recall, right? What this is, sample mean, right? Has the bell curve, right? With sigma over root n, right? That's random sample. This is what we have, right? And this guy, we don't know, so we use this guy to estimate, right? So this is a way to estimate how accurate your sample mean is, right? The larger, the worse of your estimate, okay? And interval estimate is to combine these two approach, right? Your point estimate, how accurate they are, to give you interval. So I hope that become easier. And the question being asked is, what is this guy, right? This guy again is accuracy of our sample proportion, right? Because sample proportion is what, right? You want to know yes, no data, right? You ask how many people say in the CHK like, I know spicy food, right? That underlying there's a high number of people who like it, right? And what we do is collect some sample. Maybe I ask this class, right? The sample I have, how many people like it, and then I come up with how many people, the proportion is a p, right? Proportion of people like it, and I want to know how accurate is this estimate. The way to do is this p, the sample proportion 1 minus proportion over n. That's the way we estimate.
That is it. That is what is the sample variance of that, right? It's estimate. Of course, this is a little bit biased, but this is what we use, right? Otherwise, you have divided by n-1 should be, but we don't bother. Okay. I hope I answered the question. If not, then just ask me again. What's difference? Oh, that is underlying what we have. Okay. So when I tell chapter 4 and chapter 4 tell us the foundation, right? Chapter 4 tell us if we collect the data in a simple random sample, the sample mean under law of large number is a bell curve. That is central limit theorem tells you. Okay. But the fact that you don't know sigma, then that thing become a T distribution. Okay, we'll use it immediately now, but that is something we said in the chapter 4. Okay, chapter 5 today is applying that thing, right? Because we know this is a bell curve, so we know that we plus and minus the Z alpha over 2 is how we construct the interval estimate. So that is how we do that. And T will be immediately talk about that. Because we don't know sigma, we will T. I hope I answered the question. I like using Z-score. We did in this yeah, that is what we do. I mean, that is how Z-tar is complicated. I still don't understand stat table. Okay, stat table is very simple. Stat table is this. Stat table is like this Z, which is normal CO1. 1 is here. Sorry, 0 is here. The variance is 1 in this thing. Stat table tells you the following. Give me this number. Sorry, give me this number. I give the area. Right? That's F of Z, right? The F table. CDF, right? The cumulative, the thing is the area on the left-hand side. Right? Then in Excel is the normal dot as this true. Right? And if you want the area go back, is norm dot s dot inward, right? You go for the number to the, you go from here to the number, norm dot s dot this. From here to here is norm dot s dot inward. Okay. Don't worry because we will be using a lot of time. Again, like math, you only know it when you do it. Okay, I tell you how to do it. If you don't know, it's the simplest way. I think probably you learned from math class is cover my example, do it again, whether you know it or not. Okay, so that's the way you should do, right? Just what I said is, if you still don't get it, you should go home, okay, without doing the assignment. First is you just like say this, okay? Here I give you the answer, okay? So you would just go home and maybe this. You cover this guy. Oh. You cover this and try to reconstruct what we are doing. If you know, understand every single step, then you're done. Okay? Our class is not very demanding, right? Just the green thing, you know how to do it, then we pass the class. But of course, you sometimes want to know more background that I'm focusing on, because to pass this course or to know how to operate is very simple. So the thing is, I want to give you more background why this is right, why the formula is this. Hopefully you get some of them. If you don't get it, doesn't matter, because if you actually need to know, you already go to the other advanced class, and then they will teach again, then you will try to go back and check. Right? If you actually don't go further, the green thing is the maximum thing you need to know. Right? Just apply the formula and you're done. All right. So hopefully I answer your question. But if you don't, because we're starting to get more difficult, right? I mean, to be honest, what we cover up until now is just high school syllabus if you learn statistics. So there's nothing really high level, right? If you pick any, in Hong Kong, any M1 textbook, is in high school is already there. Okay? Up until the next topic is everything is on the high school textbook. So only the ANOVA and the regression is something in the graduate in the undergraduate level. Okay. If you still don't understand, please do ask me next class. I can explain again. So that is the reason you reply, you ask me. Okay, or you should contact TA. Okay. Well, I don't want to take, but because someone said, I mean, I should reward people who are here. In case I forgot your face, because usually I remember your face, but you say you worry about I have bad memory, which my 95% I think I have good memory. So if you worry about the 5% that I have there, okay. Don't even know what to ask. Well, again, ask TA. If you don't know how to do it, please email TA to do it. But if you really don't know what to ask, just very simple. Do the assignment, or do the example, the basic thing. Okay? And later I will release the last year past exam paper. I think we're 1 hour exam at the end of this class, not the class, at the end of this course. Okay, so it's 1 hour open book exam. Okay, so you will know what I'm asking. Good luck, midterm. So 95% you will be doing very well. So there's 5% there. Thank you very much. That's yes. We have eventually have a unanimous agreement on what day today. This is yeah, please do your assignment as soon as possible because it's the way you learn. Yeah, too much information. Well, the information we only have this guy. This is what we taught only for this class, for this first half of the course. Only this one. Just remember this one. And of course, there's several terms. This is called ME, 2 times that of 2ME. You minus the guy that called LCL, the higher one is UCL. That's it. That's the only slide we learned, right? I mean, the other thing are just for the background, what it is, right? It's like 90% of time or 95% of time. What we do should include that thing, right? The probability, right? Or we do 100 of them, 95 of them should include. So that is what we are saying, right? There's nothing very deep here. I hope that would make you feel better because there's nothing very deep there. The speed is okay so far. I think just one people are not happy, and you can also follow most of you. Okay. Let's see what comment we have and see if we have time to go over some of the fun. So we have free Instagram. First is life is keep on learning. Yes, I think that is what we do, right? The problem is like we have AI. So AI is keep learning. If you're not learning, then you will soon outpaced by the AI. As an economist, I can tell you that. Very soon, if you don't learn, then very likely that your future will not be very bright. So I guess it's another food. So try to go there, have fun. I think the chef is very good at cutting, right? Cutting noodle. Okay, but looking at what he likes, maybe he is good at cutting other things as well. I don't know. I mean, I have no idea. I've never been to that part of the Hong Kong. So, what is it about? Let's
play together in an NBA game. This is all in the family. And what a celebration for the James family. Ronnie's brother and sister.
So I guess brother and sister come to his games so that he is happy. Okay. So tonight, your midterm, so call your family to come to CHK and then support you. So last one, let's see what do we have. Oh, we have a big fan of James going on here. Is it?
好似冇 copy
未 copy
到。
Is I didn't copy this one?
呢個
呢個頭先
呢個係籃球。
Same?
一樣啫。
Same. So I think you really want your family to come. Okay. So please do bring your family to your quiz. Or you're welcome to bring your family to the final exam for this class because the topics over there, they can wait outside and then support you. Or if you need it, then we can maybe have a chair sit here to support you. I don't mind that. You can hire some cheerleader goes on. That will be fine. FN is what? Final, I don't know. And have interview later. Bye bye. Okay, bye bye. What is dogma? I don't know what's that, but thanks. So let us just remind you, the main thing in this class is this formula. Okay? If you forget anything, there's a formula, right? And usually they see that alpha over 2 is just 2. 1.96 or 1.7, 1.667 or 2.1 something. Depends on what you're looking at, 1.2. So it's around 2. Okay? So that's why it's 2 sigma rule, right? That is the rule behind. But anyway, now I think we can get to the next part. Yeah? We just give it another formula there. We don't prove it, but the same idea. Okay? Because we don't know sigma square most of the time, so we place it by S, the sample variance. But in that case, we need the assumption that the underlying Bell, the data, the population from Bell. Okay? If that's the case, then we can replace everything by T. Okay? But do note that T depends on the sample size, right? If you have large sample, they become a normal. Right? So that's why the same formula applies. We don't prove it. This is the formula to remember. So these are the second formula in this class, right? Just replace the Z alpha 2 by Tn minus 1 over, right? That is the formula. And you have the S. So just to remind you what is the crucial here is this is no longer sigma square, no longer sigma. And before this is Z alpha over 2. Okay? That's two things. I think we should have example to demonstrate what's going on. Is that okay? So this is the formula. Let's go to example, and this is what we need, right? So this is the example like this, okay? Amazingly or embarrassingly simple. So we have a random sample with sample size of N20. Sample means 3, standard deviation. Sample 1 is 12, right? It's never natural. So the question is, I want to guess what is the population mean, right? This is data, right? You only go to get is only a sample, okay? But now with the assumption that the underlying is the normal, okay? The best guess is the sample mean, which is 3. So you want to guess, okay? What is the number? That's 3, right? Maybe this is a question asking, on average, how many boyfriend or girlfriend you have in the past, right? The sample mean is 3. That's what you guess is the population. And the T, right, is, remember the formula like this, right? If you recall the formula, right, will be X bar plus minus Tn minus 1, 95%. So this is alpha over 2. Alpha is 0.05 here, the notation what we have. So alpha over 2 is 0.025, right? And S over root N, right? And we know everything there, right? Because X bar is 3, S is 12, N is 20. Only this guy is not known, right? So this guy is T9005, okay? So we can use the T dot inward to do it, right? Because it's look back. This guy is just T dot inward, okay, 0.025, 19, then we're done. Okay, so let's show you the Excel in case you are not fully comfortable with that. So we just go down here, T dot inward 0.025, 19, -2. But doesn't really matter because plus and minus is just the other side, right? So if you don't like the negative, then we can use the 975. Because left and right, right? Because 95 in the middle, both sides are 2.5, right? Either you take 2.5 or 97.5, the same thing. Because this is T is also a bell, right? Because it's just a bell that press a little bit, right? How much you press depend on the number of sample you have, right? If the sample is very large, then you press a little bit, right? If the sample is very small, you press a lot. Okay. So you can see there's much more than 1.96, right? Because you press a little bit more. So it's just a little bit further away, to 95%. So what it said is the 95 interval is like, it's very large, the error. So that means that this is much larger, right? Because you only have sample of 20, right? So usually the sample is more than about 100, then the error is much smaller, right? So that is actually a side step is when your big data, say when n is 1 billion, right? Or 1 million, there's no difference between point estimate and interval estimate, right? Because you take that guy, m is almost close to 0. So when we have a very large data, that will be the same thing, almost the same thing, right? But usually we don't have that much big data, right? So that's why we don't. Is that okay? So we just learned 2 new formula there, and do remind yourself that this is the one actually used in practice, right? Because of the fact that you really don't know sigma unless you have a very rare scenario that you know sigma. And this is the thing you should proceed, right? Because you collect data, you have the sample mean, you have the sample variance, then you're done, right? The only thing you need to make assumption on is the underlying is actually a bell, right? So, but of course, whether this is right or wrong, up to you to decide. But if the underlying is not the bell, is other shape, then you have another formula there. But this is way beyond the scope of our introductory class to cover those. Okay, if you assume the underlying has something else, then there will be something else down there. Then, but the idea is the same: the plus minus 2, plus minus of something times the standard error. Okay. Is that okay? So lastly, this is the last part before we go to the next part of the sample size. Is this for the interval binary data, right? So it's very simple. For binary data, what we have is this is the P, the sample mean, right? Right. This is sigma square, right? But we know that sigma square can be estimated by P times 1 minus P, right? And when n is large, right, this is normal, right? We learned that is central limit theorem, right? That happened. And that is a good approximate when np and n times 1 is 5. As long as this is satisfied, we're done. Okay. So the good thing is we don't need t. We don't need t here. So that's why I said, right? If we don't make assumption, but if it's binary data, because binary is coming from Bernoulli, right? Binomial distribution, and binomial when NP are large enough, that's normal. So everything looks very nice. We don't really, the normal is come from directly. Let me repeat the statement. Why this apply? We don't need normality assumption. It is because binary data is yes or no, right? And yes or no is a binomial, right? Something binomial related binomial. And when NP and MSP is at least bigger than 5, that is a normal. Okay, so that is actually basically a normal, right? As long as the first statement is said here, NP and MSP is 5, that's normal. And when it's normal, we apply this. We don't need T. So we don't need T with binary data, yes or no question, because the normality is given under the assumption there. But if not, then actually you have to say this is binomial, then you do something different. But in your application, this will satisfy. And in medical experiment, this will be not doing. You have to have some adjustment. But I think for most of you are not doing medical study, so that's why it's fine. Is that okay? There's a formula here. Okay. So we have 3 formula just to remind you for this up until now. This first formula apply for binary data. Okay. We don't need to estimate the sigma. Okay. But the binary data bias this guy and bias this guy. Okay. This is the first formula. This is the third formula. The second formula, this formula. You know how to do that. And the formula I have here is this formula. Okay. The 3 of them. Okay. The example like this. Okay. Now we have N64. Okay. We are 64 person whether they like spicy food. Okay. And at the end we have a quarter of them like spicy food. Right. So then I want to guess what's going on in the population. Then what is the best guess? A quarter of people like it. Right. And but then you want to have a better estimate. Then you apply the formula. Right. Remember the formula, right? Will be, you pick it up, will be P plus minus Z alpha over 2 square root P 1 minus P over N, right? And P is given, so it's here is done. This is done. This is done. N is the sample size 64. We're done. What's left with this guy, right? But we know that, all right, 0 here, Z here. We want 1 minus alpha here. And this is alpha over 2. And this is alpha over 2, right? We call this guy negative Z alpha over 2, right? We have that already. So how to find that? Norm dot S dot inward. You're looking at 95. 2 side up to 5%. 1 side 2.5. So it's norm dot S dot inverse 0.025. Left hand side, if you don't want that, you want that is norm dot S dot inverse 0.975. So both will give you 1.96. Okay, that's almost 2 as with that, right? Just apply the formula, done. Okay, so we will say if the data what we have is a quarter people like spicy food, then will be 40% up to 35% like spicy food. That is what we have. So that's application. Okay, so that's very easy, right? Because that is actually what people do in US, right? If you ask people, you vote for Trump, yes or no? Then you look at that, okay, for a quarter of people vote for Trump. That is the thing. And then you will say, okay, the margin will be plus minus 10%. That would be the idea, right? Of course, you collect more N, then this range will be very small, right? Is that clear? So the question probably with the end of the rest of the chapter is how to decide the N, right? This is the question, right? The more N you have, then the range is getting shrinks, right? So we can talk about the question of how do we design our sample size, right? Because of correct data, we have to decide how many people to ask, right? When to stop, right? So that is the part that we'll talk about the next part. Okay? Is that okay? So the 3 formula we have today. Sample size. Okay. So don't worry about the last part. This part is again super easy. Actually easier than what we have. It's based on the formula we have already. So the formula is very simple. So we already know that if we try to estimate the sample mean, right? The interval estimate is by this formula ME, right? I hope you have seen it many times already now. So this would be something we know. Okay. And now we ask the question is we want at the end of the day, we want to estimate with good accuracy. So the boss tell you what is my ME, right? I want to estimate precisely. So I tell you in advance what's margin error, right? I want it within 0.01 or 0.1 or 0.2 that is given. The boss tell you how precise I want, right? Then I want to know the n, so I reverse the equation. I give the ME, I tell you the confidence level, say I name 95%, that Z will be 1.96, right? The sigma, suppose I know that, right? Then I can find n, right? I reverse the order. So you can see if I do that, this is my formula, right? I make n the subject. I square everything there. I move n to the other side, move ME to down. This is the formula I have. Okay, and you see this is a ceiling function, which means that if I have 15.6, I use 16, right? Just round up, right? This is a round up function, right? Okay, let's see the example. This is something trivial, right? Because I know the ME formula, right? And I just know I give the ME, I want to find the n, right? Just very simple. It's primary school math, right? I give the ME, give you this, I want the n, right? Okay. Primary school problem, right? This would tell us in advance, if I know all this, how many n I collect, and once I do it, at the end of the day, this ME I give will be within this range, right? So this would tell us in advance how many sample I got. If I have good estimate of sigma, right? I told you how to estimate sigma already, right? If you know what the number can be there. Okay, so it's very simple. Here, just apply formula. So we only have 4 formula in this, 4 or 5 formula in this class. So a formula there, right? Just to write the formula again. N is a round up function. We have ME square. You just write ME. You actually you don't need to remember. That's how I remember, because I don't want to remember something I don't need to remember. You just move the n to the other side. So that will be Z square alpha 2, right? And sigma squared, right? Just move it to the other side, move the other side, square everything, right? So this guy we know already very well is 1.96, right? If you 25%, right? Just to remind you how we do that is norm dot s dot inward 0.025 or 0.07, 0.975. That's how we get it. And ME is given by the boss. Tell you within 4, right? I know this is 10. How I know it? Boss told me. Okay. So the boss told you this is or some prior study you know this is, right? You plug in all the number there, turn this 4.01, then actually I told you that this is 25 sample, then we're done. So I just need to talk to 25 people. That will be within 4, within the 4 margin error is 4, right? So we are confident that 95% that what we do will include what we want. Is that clear? So nothing deep there, right? There's nothing very special there. Just apply the formula reversely. Is that okay? Is that okay? So here is the same, but we have binary data. Okay. The formula say like this, we just reverse it, put n there, that's what we have, right? There's nothing new there, right? If I want to have some desirable property there, right? I know the pi, okay? then I can apply this formula. Okay, I have some idea pi is this going to be from prior study. Pi is 0.9, pi is 0.8, pi is 0.6. Okay, that is the formula I apply. Okay, and you just plug in all the number there. You figure out that is 98. I'm not going to do it, but that is the formula, right? This is right. P times 1 minus P. Right. The formula is like this, right? Pi 1 minus pi z square me square, right? And this guy is 1.96, we know already, right? And these are coming from the boss tells you. And this guy is the boss tell you the margin error, right? So plug in, calculate n, you need 93 observation. Okay. So probably the question in your head is, why I need to, how can I know the pi? If I know the pi, what I'm doing, right? If I know the pi, why I'm doing that, right? That's crazy, right? If the boss tells you the pi, why I'm doing it again, right? Maybe from prior study, you know the pi, then we can do it. But we'll tell you that how to figure that out. Okay. The reason is being, we actually did not know this pi. The reason is the following. If you recall the formula, the math, high school math, pi is run from 0 to 1. Pi times 1 minus pi from high school math is a curve here. 1/2 give you a quarter here, right? Remember when we learned this binomial, right? Pi times 1 minus pi, the maximum appear at middle, 1/2. So we want to be conservative, right? Do the max, right? No matter what the actual pi is, we do the maximum, then that will give us the, we always can get what we want, right? Without knowing that. So that's why at the very end, we have this formula. Okay, right? So I don't have that here. But basically, in this model, you use 1/2. Then we're done. Okay. So that's what usually what we do in the following example here. Okay. So I don't know what the proportion is. Okay. I want to calculate the sample size for confidence 95%. I want to within 1%. Right. Suppose I want to see how many people like spicy food. And I have no idea what's going on. Right. So what we're going to do is assume pi is 0.5. That is the most conservative one. And I apply the formula 2 square times a quarter over the margin error 1, then you get 97. Right? So we're done. Right? So if you, this is 10%, right? Suppose you want 1%. 1%, that means that we need to have what? How many you want? 100 more, right? So if you have like around 10,000, then it's 1%, right? The margin error, right? So basically you ask yes, no question. If you have asked 10,000 people, then it's already very accurate, right? And right, so that is what we want, right? So I guess that's what we need to say at the end. And what remains Excel, I'm not going to cover them because this is just give you shortcut to this formula, and I don't think we actually need them. If you need them, you can just take a look, but this is the Excel formula, give you directly this guy. But we know how to calculate everything there already. So I don't think this formula will actually be used. I actually never use it because I used to do it from the first principle. You can use this, give you this guy, but usually I don't. But if you really want, you can just use this confidence norm, confidence T to give you what we want. Okay. And I guess I should end here. So I will ask the TA to start releasing the new assignment because we're done. But again, you given 2 weeks time to do it. Okay. So the two. Okay. So you want some more time? So I mean maybe this way. We consider the new assignment to be released in next Monday. So we give you like 20 more days to do it. So we'll be officially released. We release, but we consider officially release next Monday. Okay. So you can enjoy the midterm. Forget about our assignment. I mean, but you can do it if you want to do it over the weekend. Okay. So have a nice day. I'll see you next week.